Advanced Algebra, Chapter 7, Lesson 1, and we're going to begin this chapter by looking at roots and radical expressions. We'll talk about the definition of roots and radicals to begin with, and then we'll look at simplifying these radical expressions that have variables in them. Roots we've talked a lot about, primarily talking about square roots. We talked about the square root of 25 is 5 because we can multiply 5 by itself and get 25. However, if we take the number 5 and multiply it by itself 3 times, we get 125. So we can undo that by taking the cube root. Or if we raise 5 to the 4th power, getting 625, we can undo that by taking the 4th root and the 5th root and the 6th root, etc., etc. So pretty much we can take any root or the root of any number that we want applying this pattern. So even though we're mostly comfortable with working with square roots, we're going to look at these higher root that we can also use some of the same things that we've done with square roots. So this pattern simplifies to this kind of definition of an nth root, and basically it says if you take a number and raise it to a power, then that number is a root of the value that you get when you raise it to that power. So the nth root of b would be the value a, or the number that you raise to that power. That may sound a little confusing. Don't worry too much about that. We'll try to clear that up as we move forward. Now, we're used to seeing this root sign. This sign is called a radical. That's why we call these radical expressions. So this sign you're used to seeing. You're not used to seeing probably a number written in here, because if a number is not written in there, it's understood to be a 2. But we can actually write any number in here that we want. And this number is called the index. So we could write a 3 here. That would mean the cube root. We could write a 4 here. That would mean the 4th root, 5th root, whatever number we want. The value underneath this radical sign is called the radicand. So we'll see, we should know these terms so that when we're talking about them we're not confused. So the number underneath that radical sign is called the radicand. The number that you'll see written here now is called the degree of the root, or the index of the root. And the positive number that you get when you're taking the square root is called the principal root. Now this is mostly what you've dealt with as you dealt with these in the past. In other words, when someone asks you what's the square root of 25, most of you will say 5. What you're giving is the principal root, because there is another number that you can multiply by itself and get 25, and that's negative 5. So when you give the principal root, you're just giving the positive root, even though there may be a negative one. Okay, so it's important to know that vocabulary there. Now, because we're going to be talking about different indexes, we want to look at the types of numbers that we can get by doing this. So this chart will summarize the types of roots that you can get based upon the type of radicand that you have. So this number in this column is going to represent the different types of radicands. And then this column will indicate even indexes, or even roots, and this column is odd indexes, or odd roots. So if you have a positive number as your radicand, but you have an even index, a 2, a 4, 6, or 8, square root, 4th root, whatever, that's going to produce two answers, both a positive root and a negative root. The positive one is called the principal root, and we do have a negative one, however. If the radicand is negative and the index is odd, 3, 6, 9, no, not 3, 6, 9, that's counting by 3s. 3, 5, 7, 9, any of those, because those indexes are odd, there's only going to be one root for that particular problem. If the radicand is 0, then even root will produce just one answer. The square root of 0 is 0. And an odd index, or odd root, will also produce just one answer. Cube root of 0 is 0. Now, if the radicand is negative and the index is even, that's an undefined number, because as we've talked about before when we were looking at quadratics, when you have the square root of negative 4, you can't do that, so we introduced imaginary numbers to help handle that. But we're talking about just real roots now. So you cannot get any real roots if the radicand is negative and the index is even. So that's 2, 4, 6, 8. If, however, the index is odd and the radicand is negative, you can get one root, and that root will be negative. Okay, so you can get these different types of answers depending upon the radicand. So an even index with a positive radicand is going to give you 2 roots. An even index with a negative radicand will give you no real roots. Odd index with a positive radicand will give you 1, and an odd index with a negative radicand will give you 1 as well. So that's what this kind of summarizes, and the more you work with these, the better you'll get at understanding these. So very quickly then, to summarize the types of answer, you should know what type of answer you should get before you actually do the problem based upon what we just talked about. Now, remember, if you're asked for a real number root, okay, for a root, something like numbers 13 through 20 down here, that means we simply want the principal root. So the square root of 36 would be 6. The opposite of the square root of 6 would be negative 6. The square root of 36 is 6, and then the opposite of that is negative 6. Okay, so that's okay. This negative radicand, however, because the index is even, there are no real roots, it's undefined. This one would give us 1 root, 0.6. This is a cube root of a number, so you will have 1 answer there. Here's a 4th root, so you'll get 2 answers because it's an even index, but they only want 1, so we'll give the principal root here. This one has no real roots because this is a negative radicand. Okay? In these other values up here, you should be able to find all the square roots. That means it wants both the principal and the other one. So here you should have 2 answers. Here you'll have 2 answers. This is a negative value, so this one would be none. There are no real roots. Cube roots, you should have 1 answer for each of these, whether it's positive or negative. 4th root, that's an even index, so a positive number will give us 2, a negative number will give us none because that is undefined. Okay, so that could kind of sum up what our introduction is as far as radicals go, and we should be able to do these fairly quickly moving forward.